Hello student and welcome to our course Electrical Machines and Control. This is Raid Al-Malki with you. Inshallah, we are going to have a video inshallah each time for week 1 and week 2 up to the end. This video is going to be shared with you inshallah in Blackboard. Let's go to the next slide. Inshallah, in this course, you are going to learn sinusoidal alternating waveforms. Inshallah, in week 1. Week 2, we are going to have basic elements and phasors. Week 3, inshallah, we are going to learn series AC circuits. 4 and 5 for parallel circuits. 6 and 7 active, reactive and apparent power. Starting from week 9, inshallah, we are going to have 3-phase transformers, 3-phase induction motor principle, and for week 11, inshallah, we are going to learn selection and application of 3-phase induction machine. Structure of automatic control systems will be on week 12. Controlled circuits and method of operation, week 13, and the last 2 weeks will be in electrical DC generator. I already put the references, as you can see here. The first one is Robert L. Boylested for introductory circuit analysis, 13th edition. The second one is Theodore Weldy for electrical machines, drive and power systems, 6th edition. You can refer to those books, inshallah, to have more information regarding our topics. Okay. For lecture 1, inshallah, we are going to talk about sinusoidal alternating waves. Inshallah, for this video only, we are having an introduction, sinusoidal AC voltage characteristics and definitions. Inshallah, we are going to show you the AC wave. What are the definitions for each element in the sinusoidal alternating waves? We are going to also we are going to have a general format for the sinusoidal voltage and current, average value, effective RMS values, and examples and homework at the end of this video. Okay, what is an alternating waveform? As you can see here on the left side of the presentation, the term alternating indicates only the waveform alternates between two prescribed levels in a set of time. Okay? Okay, it is okay. This is sine wave. Okay? This is square wave. This is triangle wave. All are waves. So when I say alternating, it is alternates between two levels, which is this level and this level. So we have positive level and negative level. Okay, to be absolutely correct, the term sinusoidal, square wave or triangle must be applied because they are all alternating, guys. Okay, they are all alternating. They are all having two levels. This is level number 1. This is level number 2. This is level number 1. And this is level number 2, and it is applied for the sinusoidal wave. Now, the pattern of particular interest is sinusoidal AC wave. One of the important reasons for concentrating on the sinusoidal AC voltage is that it is the voltage generated by utilities throughout the world. That's why we are going to focus on the sinusoidal only wave. We are not going to have any information regarding the square wave or the triangle because we are having AC like this one, sine wave, almost in Saudi Arabia and all the utilities around the world. Okay. Now, sinusoidal waveform, okay, or sine wave, okay, guys, is the fundamental type of alternating current. Fundamental معناتها الأساسي يا شباب. Fundamental type of alternating current AC or alternating voltage. So we have two types here of sine waves, okay. We have current, we have voltage, okay. That's why we're having here, guys, voltage as you can see, and current here. So you can have sine wave for voltage and sine wave for current. Okay, here is the positive side, as I told you. This is the positive side. This is the positive side of the sine wave, and this is the maximum. Okay, this is the maximum point here. This is the maximum point. Okay. Now, for the negative side, this is the negative side of the sine wave, and this is the maximum negative side. Okay. Either it is voltage or current, we don't care at this in the time being. Okay, we don't care if it is voltage or current. It is applying for the two. Now, what is the sinusoidal waveform? There are various types. There are various types of generating AC power. Like we have here the power from the electrical company, as you can see here, and here a normal diesel generator. Here from the wind. Here from the sun. From the PV. And here also from a generator, which is called function generator. Okay, so all having here AC sine wave. Okay, this is AC also, this is AC. In each case, an AC generator also called as an alternator. So we can call an AC generator, we call it alternator, because the sine wave coming out from the generator is alternating sine wave. Alternating sine wave is the primary component in the energy conversion process. So as you can see, from each type of generating power, the types here as you can see here, each one having a generator, and the generator will give you an AC wave. Okay, an AC alternating wave. Now, the terminologies for a sine wave you should know. First one is the waveform. What is the waveform? The waveform, to be exact, this is the as you can see here, this is called a waveform. It is the path traced by quantity, such as the voltage in figure 13.3, this is the one, plotted as a function of some variable. So it is a function, okay, traced by a value. When I say traced by a value, so I have value here, and I have value here, and I have value here, I have value here, I have value here, I have value here. At any time, I have value here, I have value here. This is a quantity, okay, function plotted with some variable. What is the variable here, guys? We have here the current variable or the voltage variable, and with time. Okay, so such as position, degrees, radius, temperature, and so on. Okay, and instantaneous value, the magnitude of a waveform at any instant of time. So when I say what is the instantaneous value? Let's say the value here. Instantaneous means for the time being now. When I when I put my finger here, okay, guys, what is the value of this point? So this is the value. This will give you a value with time. So at this time, let's say 2 seconds. Okay, what is the value here? So I should know the value here because I already specified the time. So I should know the value. Okay. Now, what is the peak amplitude? It is the maximum value, peak amplitude. It is the maximum value of a waveform as measured from its average or mean value, denoted by uppercase letters such as EM. Okay, so this is the EM. Okay, so from here to here. For sources of voltage, and VM for the voltage drop across a load. This you will get inshallah in the coming videos inshallah. For the waveform in figure 3.3, the average value is the 0 volt. The average value is the 0 volt because why it is 0? If you can see here, this point is almost the same as this one. Okay, what is the average between this point and this point? It is 0. This is the average value. It is 0 because they are almost the same. The positive maximum value is equal to the negative maximum value. Okay, guys. So the average value is 0 volt and EM is as defined by the figure. Okay. Now, what is the peak value? The peak value is the maximum instantaneous value of a function as measured from the 0 level of volt. So the maximum or the peak value, when I say the peak of the mountain, I mean the tip of the mountain, it is at the maximum point here, as the maximum point value from 0, from this point to this point. This is the maximum or the peak value. Okay, the peak value. For the waveform, the peak amplitude and peak value are the same since the average value of the function is 0. So this is a condition. When I have 0 average value, which when I say 0 value, 0 volt, I mean that this portion or this portion of the AC wave is equal to this portion. So the average is 0. Okay, the average is 0. When I say the average is 0, then the peak amplitude is equal to the peak value. They are the same actually in this type of AC waves. Okay, peak to peak value. Let me just delete this one. Okay. Okay, the peak to peak value is the value between two maximum points. This is from here to here. This is a peak value, peak to peak value, peak to peak, from tip to tip, peak to peak, and from here to here. Okay, this is also a peak value. So peak to peak value. Okay, let us read here what is the peak to peak value. Is denoted by EPP or VPP, as shown in the figure, the full voltage between positive and negative peaks of the waveform. That is the sum of the magnitude of the positive and negative peaks. Okay, as I told you, it is from here to here or from here to here, guys. Continuing the terminologies for a sine wave, periodic waveform is a waveform that continually repeats itself after the same time interval. Okay, after the same time interval. The waveform in the figure 13.3 is periodic waveform. So it is from here, guys, and it is repeating itself, and it is repeating itself, and etc. خلاص guys, this is periodic waveform. They have the same they have the same values of the maximum points here and here, and it is repeating itself. Okay, that's why we call it periodic waveform. Period. This is very important term in this video. The time of a periodic waveform. So this is the period, the time of the periodic waveform. This is the time t. See here, this is t1, or the first one. So it is from here, okay, up to here, okay, or from here, sorry, or from here to here. خلاص guys, so it is one full wave, but this is the time. Okay, this is the time. So the cycle is, we can take a cycle. The cycle now, cycle is one complete wave. Sorry, one complete wave. This is one complete wave. This is a one complete wave. If you start from here, you should stop here. If you start from 0, you should stop at 0. If you start, let's say here, 1, okay, start at 1, you should end up in the same value 1. So if you start by 10, you should stop at 10, and that's it for the cycle. The portion of a waveform contained is one period of time. So a cycle is having one cycle is having a period of time, means the period is one cycle, okay, but it is in time, period in time. The cycles within T1 and T2 and T3 may appear differently in figure 13.4, but they are all bounded by the one period of time. اوكي يا شباب، هذه هي نفس هذه، هي نفس هذه، لأن الوقت البيريد حقها كلها نفسها. تمام، تعتبر هذه سايكل وهذه سايكل وهذه سايكل، كلها نفسها يعني، بس إن متى بديت تنتهي، بديت بصفر تنتهي بصفر. خلاص. ف this is one cycle guys, and one cycle has a period of time. Okay. Now frequency is the number of cycles that occur in 1 second. Okay, when I say guys we have a frequency in Saudi Arabia, we have 60 hertz. Okay, I mean that it is having 60 okay cycles per second. So the waveform is repeating itself 60 times in 1 second, guys. Okay, in 1 second, this circuit, or this AC wave is repeating itself 60 times. Okay, 60 times per second. Okay. Now, if I, as you can see here, if I decreasing the period, if I decrease the period now to 0.4, see, now the wave, the cycle is now smaller than this cycle, right? So I should have more frequency here than here, because this one is 1 second and this one is 1 second. So I have 1 second. Please guys focus here. I have 1 second here for time period, and this is 1 second. One wave, one cycle in 1 second. How many cycles I have it here, guys? I have one cycle because I start from 0. This is 1. I have 2 cycles. This is number 2, and I have another half cycle. Okay, this is in 1 second. Here, if I have the also 1 second, the time period is 0.5, so I have 1 cycle, 2 cycles in 1 second. In 1 second, guys. Okay, so the 3 graphs that we have here, we have the first one on the left side. We have 1 cycle in 1 second. We have here 2.5 cycles in 1 second. We have here 2 cycles per second. Okay. The unit of measure of frequency is hertz. Okay, this is hertz, where 1 hertz is 1 cycle per second. Okay, guys, this is very important. Now, let us go to example number 1. Believe me, guys, all the examples that I have here, it is there in your textbook. You can just refer to the textbooks that I already mentioned in the second slide. Go there and check the questions. Okay, for the sinusoidal wave here in figure 13.7, this is the 10.7. What is the peak value, guys? When I say peak value, I mean the maximum, guys, the maximum point. What is the maximum point? This is the maximum point, 8. Okay, this is the peak value. Now, what is the number B, or part B? What is the instantaneous value at 0.3 seconds and 0.6 seconds? What is the instantaneous value? So let's go to here. This is 0.3. Okay, 0.3 seconds. The value is minus 8, so this is correct. 0.6 here, the value is 0, which is also correct. So the value here is 0, guys. Okay, now what is the peak to peak value of the waveform? Peak to peak, from here. Okay, this is the peak to peak value. Okay, the peak to peak value, peak to peak value is equal to 2 multiplied by peak. So 2 multiply 8 is equal to 16 volt. This is 16 volt. Okay, guys. Now, what is the period of the waveform? The period of waveform. When I say period, guys, let me just delete what I write here. Okay. Okay. Now, it says that what is number or part D? What is the period of the waveform? When I say period, I mean time. This is the sign for the period. Okay, period is equal to the period is the 1 cycle. Try to find 1 cycle. Okay, 1 cycle. Find 1 cycle and write in seconds. Okay, second. So this is one cycle, guys, from here. Okay, this is one cycle. So starting from 0, okay, up to 0, or come back to 0. Okay, it is 0.4. So value here is correct, 0.4. Okay, how many cycles are shown? This is cycle number 1, this is cycle number 2, this is cycle number 3, this is half cycle, so 3.5 cycles. Correct. Now the last question, or last part of the question, what is the frequency of the waveform? Okay, now we are going to have it for for hertz. Okay, for hertz. The frequency of the waveform is basically f equal to, okay, 1 over t. Okay, one cycle, and t is 0.4 seconds. Okay, it is equal to 2.5 hertz. Got it, guys? This is the this is how to find the frequency of a waveform. If you have a period of time, if you find the period of time, you can find the frequency. If you find, or if you have the frequency and you need to have the period of time, just only interchanging between the two here. So t is equal 1 over f. Let us find the period again. 1 over 2.5 is equal to 0.4 seconds. So t is in seconds, f is in hertz. Class, guys. Okay, this is all about example 1. Now, the sinusoidal wave form, it is the sinusoidal, the sinusoidal waveform is the only alternating waveform whose shape is unaffected by the response characteristics of R, L, and C elements. So if I have resistive load, the shape will not change. If I have inductive load, the shape of the the shape of the AC wave will not be affected. If I have capacitive load, also the shape of the AC wave will not be affected. In other words, if the voltage across or current through a resistor, inductor, or capacitor is sinusoidal in nature, the resulting current or voltage, respectively, for each will also have sinusoidal characteristics, as shown in figure 13.12. If any other alternating waveform, such as a square wave or a triangle wave, were applied, such would not be the case. Okay, let us focus just only on the AC wave. So if I apply voltage to a resistor or inductor or capacitor, the resulting AC wave will be having the same sinusoidal wave characteristics. Okay, the sinusoidal waveform also we are having here, yes, 1 radian. Okay, now we are having the radians and degrees. The circuit, remember the circuit, guys, here. Okay, this is the circle, sorry, the circle. We have here 0 angle. Okay, we have here 90, we have angle here 180. Okay, sorry, yes, and we have here 360. Okay, we have here 240. Now if I need it to be having radian, I have here 0, I have here pi over 2, I have here pi, I have 3 pi over 2, I have here 2 pi. خلاص. So this is very important. Inshallah, we are going to have it in details inshallah in the next or the coming slides, but I'm showing you what is 1 radian, okay, what is the degree, and how to interchange or to calculate degrees from radians or radians from degrees, okay. 1 radian is equal to 57.3, where 57.3 is the usual approximation applied. One full cycle has 2 pi radians, as shown in the figure, okay. As I told you here, we have full wave, so this is the wave, okay. This is 1 cycle, it will end with 2 pi. It will start with 0, here pi over 2, and etc. guys, okay. So that 2 pi radian is equal to 360, as I mentioned in the circle. So a number of electrical formulas contains a multiplier of pi. For this reason, it is sometimes preferable to measure angles in radians rather than degrees. So because you know, is it better guys, is it better to have like a number like 24 pi or 24, okay, with angle 180? This is how to write the angle 180 degrees. So this is not easy like this one. So 24 pi in the calculator, it is easy to find this one because 24 pi is okay. But if you know, if you need to have 24 degree 180, you have to interchange and go to the settings of the calculator and you change it. So it is easier to have the angles in radian, okay. The unit of measurement, degrees and radians, are related as shown in the figure. The converging equations between the two are in the following. This is the conversion between the two, radians and degrees. You should have it memorized, guys. If I have radian, I want it in if I have degree and I want it to be radian, I should use this one, pi over 180 multiply the degree. And if I have radians, I want it to be in degree, 180 over pi. So it is also it is just only the opposite. Okay guys, you can memorize it as this one. If I have the degree down, I should multiply by the degree here, and I will have the radian, okay. If I have the same value here and here, radian and radian, so I should have degree. So just choose the preferable way that you want to memorize those those formulas, okay. And now just let me delete all of them. Okay. The velocity with which the radius vectors rotates about the center, called the angular velocity, can be determined from the following equation. The angular frequency is the distance, okay, radian or degree over the time, okay. The angular velocity is basically how fast the oscillation can be, how fast, okay, how fast. So this is the angular, this is how to write the symbol of the angular velocity. So I have it here and also here. Okay, but actually I need, since the omega is typically provided in radians per seconds, okay, the angle alpha obtained using 13.10, okay, is usually in radians. خلاص guys, if I use the alpha in this and the omega is already in radians, okay, so the alpha will be in radians. If alpha is required in degrees, you must have the formula that I gave you to interchange between degrees in and radians. Okay. The most important formula for the angular velocity is this one. Very important formula. Very important formula. Omega is equal to 2 by f. This is, you should memorize it. Okay, you should memorize it. Angular velocity is equal to 2 by f. 2 by f. F, I mean the frequency, okay? Because we are the angular velocity, this is the frequency for the frequency of this paragraph, okay, is 1 second, okay? The frequency is 1 hertz, sorry. And if I need to have the angular velocity is the how fast this AC wave is oscillating between negative and positive. So that's why we are having we are multiplying by 2 pi. Okay. Now example 13.4, determine the angular velocity of a sine wave having 60 hertz. So if I have 60, so 2 multiply by pi multiply by 60, we are going to have 377 radian per second. So this is the unit of omega. Omega, the unit of omega is radian per second. Radian per second. Okay, a reoccurring value due to 60 hertz. This is the if I have 60 hertz, the omega angular velocity will be also will be 377, and this is a rememberable value. Okay. Example 13.5, determine the frequency and period of the sine wave in figure 13.17b. You can find it in the book. Okay. Solution, since omega is equal to 2 by t, I will go back to the formula. Okay guys, I'll go back to the formula, I will show you. Okay, since omega is equal to 2 pi over t, remember guys the frequency and the t, the period, frequency equal to 1 over t, okay, and omega is equal to 2 pi f, and f, and let us just put f here, so 2 pi multiply by 1 over t, it is equal to 2 pi over t. Last guys, this is easy. This is how we derive the equation. Okay, now since omega is equal to 2 pi over t, t, okay, is equal to 2 pi over omega. Okay, and 2 pi is in radian. Okay, and the omega, okay, omega in the figure is 500 radian per second. Okay, so 2 pi over 500 is 12.57 milliseconds. Okay, and F is equal to 1 over T is 1 over 12.5 milliseconds, guys, because we know that milliseconds is the same as multiplying by 12 point minus 3 seconds. So I'm changing this milli to this value. Okay, guys. For kilo is multiplying kilo second by multiplying by 10 to power 3, which always we don't have it kilo, we have milli microsecond is by multiplying 10 to power minus 6 second. خلاص. So this is, we don't need it because we don't have it for seconds. We use only millisecond, microsecond, seconds. So this is how to change or to apply milliseconds in the value here, because if you don't put it here, guys, okay, the milliseconds by multiplying 10 to the power minus 3, this value will be in seconds. So this value will be changed. That's why we are putting the same value here, the same value. It is okay in milliseconds, but you should put it here also. What is milli? Milli is 10 to the power minus 3. Okay, so the number here is in seconds. If you put it in the calculator, it will be 0. If I am not mistaken, 0.1257 seconds. So this is the actual number in seconds. Okay, but rather than putting this one, and you may have a mistake, just change the milli by multiplying 10 to the power minus 3. Okay, guys, this is very important, and here is the most mistakes that we have from the students. Okay, some students forget to put the milliseconds and microseconds as a number. Now, example 13.6, given omega 200 radians per second, determine how long will it will take the sinusoidal wave to pass through an angle of 90. Okay, so since the alpha, this is angle, this is alpha. Okay, this is alpha, but as I told you, remember, this is 90 in degree. I need it in what, guys? In radians. So if I need to, because the 90 is we should have it memorized that 90 is pi over 2, and this is without having the conversions formula. It is already you can just memorize it. Is 90 is pi over 2 and 180 is pi, etc. Okay, so T is equal to alpha over omega. Alpha is pi over 2, as I said, and omega is 200 radian per second. Guys, here you should have it radian, and here you should have it radian. Okay, we cannot just put degree over radian. The answer will be wrong. Okay, so it is already pi over 400 is equal to 7.85 milliseconds. In the calculator, it will be shown like this. Okay, 7.85 multiply 10 to the power minus 3. Okay, this will be shown in the calculator. Just add by adding the unit of the time, which is seconds. خلاص guys. For me, I prefer to have it both. You can write by this this form or this form, okay, because they are the same. I prefer to have it both because I want to understand that you already understand the conversion between milli as a letter to multiplier by 10 to power minus 3, okay. Now the last example for the sinusoidal waveform. Find the angle, okay, find the angle through which a sinusoidal wave form of 60 hertz will pass in a period of 5 milliseconds. Okay, 5 milliseconds. So alpha, because it is asking about the angle, so the angle is alpha. Okay, the angle is omega. Let us just go back to the okay. So alpha is omega t here. Alpha is omega t. خلاص. So alpha is omega t. Alpha is equal to omega t, and omega is equal to 2 by f, and t will go down, so 2 by f. That's why you have it here, 2 by ft. 2 by is already here. F is 60 hertz in Saudi Arabia. That's why and it is already mentioned here. خلاص. And the time is 5 milliseconds, guys. Again, you should write, because you are calculating something, you should transfer this milli to a number. So it is 5 multiplied by 10 to power minus 3. It is equal in it's equal in equal 1.89 radian. Now, if not careful, you might be tempted to interpret the answer as 1.885. However, alpha is equal to 180 over pi, okay, multiplied by 1.89 radian, okay, and radian, you will go with radian, and it is 108.3, and this is wrong. Okay, it should be like this. خلاص. Be careful guys, huh? Be careful. Radian is just only unit. خلاص يا شباب, be careful. Now, general format for the sinusoidal voltage or current, okay. The basic mathematical format for the sine wave is AM sine alpha. AM is the maximum value, okay, of the current or the voltage. Sine is the sine wave, or you may have it cosine, and this is the angle, okay. Where AM is the peak value, it's the maximum value of the waveform, and alpha is the unit of measure of the horizontal axis. It is the angle, okay. Due to equation 13.10, the general format of a sine wave can also be written as omega t. This is the most general format for that we have, and we need it. It is AM sine omega t, because alpha is equal to omega t, remember guys. So we can just write it here, AM sine omega t, okay. This is the general format for a sine wave. Either it is voltage or current, okay, with omega t as a horizontal unit of measure for electrical quantities such as current or voltage. The general format is for I, the current, is Im, because it is I already, okay. We are measuring current, that's why we put I peak, Im Im, it's the peak value, sine omega t is equal to Im sine alpha, because alpha is equal to omega t. It is the same as for the voltage. خلاص. But we are having the voltage value, the peak value of the voltage. Now, example. Given E equal to, this is the question, guys, huh? E equal to 5 sine alpha. 5 sine alpha. Determine E at alpha is 40. And alpha is 0.8 pi. Okay? So I have two alphas. I need to have the voltage, okay, in each at two angles. The first one is 40, okay. As I told you guys, it is better to have it in radian, okay. So 5, or you just can put it here in the calculator. 5 sine 40. It will be the sine 40 is 5 is sine 40 is just only 0.6428. So 5 multiplied by this number is 3.21 volt. For the second angle, okay, it's already in radian. You should, as he did here, should put it in degree, okay? Because if I use sine, I should have it in degree, okay? Because if you use sine, let us say sine 90, okay, or I use sine pi over 2, they are having different, okay, values. So with sine or cosine, you should have it in degrees. You should have it in degrees. If I don't use sine or cosine, you should have it in radian. This is very important. So if I am using with the general format sine or cosine, okay, I should have the angle in degree. Don't use radian here. خلاص guys, this is very important. And you can try it in the calculator. Try it in the calculator and just let me know if you have all the different answers, okay? Now, the angle at which a particular voltage level is attained can be determined by rearranging the equation, okay? This is the equation in the format manner. Sine alpha is equal to E over Em, okay, from this equation, okay. So we are going to rearrange. Now, this is sine here and this is alpha. So if I need to have the alpha alone, so if I should have sine to the power minus 1, okay, E over Em. And also for the current is the same idea. خلاص, sine inverse. I should use sine inverse. خلاص guys, you shouldn't memorize it. This is easy because if you have E equal to Em sine alpha, so E is okay. We already have an example for it, and the answer is, let's say 3.61. I don't remember. Sorry, this is the one. 3.21. 3.21. Okay, but if I need the alpha, okay, I should do like this one, which is alpha equal to sine inverse E to power EM. Okay. Now, let us take an example. Example 13.9. Determine the angle at which the magnitude of the sinusoidal function v equal to 10 sine 377 t. 377, it is the omega as the general formula, because the general formula is E equal to EM, okay, sine omega t. So omega is 377, okay. He said determine the angle at which the magnitude of the sine wave function is 4. So what is 4? This is 4. Okay. Okay. This is 4. Now, alpha is equal. So this is the value of the voltage, not the maximum voltage, not the maximum voltage. This is the value of the sinusoidal function, okay, is 4 volt. So alpha is sine. So this is, this is E. Sine inverse E over EM, where E is 4 volt and EM is 10 volt. خلاص guys? So this is the answer. It should be in degree. However, figure 13.19 reveals that the magnitude of 4 volt is positive. Okay? Is positive, will be attained at 2 points between 0 and 180 degrees. So the second intersection is determined by alpha 2. Okay? Here, guys. Okay? The second at alpha 2. This is alpha 1. Because he said here, B, determine the time at which the magnitude is attained. Okay, sorry guys, no. Let me just delete this one. Determine the angle at which the magnitude of the sinusoidal function is this one, is 4 volt. So this is alpha 1. This is alpha 1. This is alpha 2. So how to find alpha 2? Alpha 2 is just basically 180 minus this number is equal to the 156.42 degrees. So this is how to find alpha 2. Okay? Now, in general, therefore, keep in mind that equation 13.5 and 15.16 will provide an angle with a magnitude between 0 and 90 degrees. Okay? So the equation 13.5, let's go to 13.5. 13.15 and 16. Yes, this is very important note. Very important note. So if you need an angle between 0 to 90 degree, you can use those formulas. But if you need more than 90 degree, you should use the alpha is equal to 180 minus that angle. You will give you the rest of the angle, okay, as it is here. Okay, the same as this one. Now, determine the time at which the magnitude is attained. Now, alpha is equal to omega t, and so t is equal to alpha over omega. However, alpha must be in radians. As I told you guys, because we are not having here sine or cosine. If I have sine or cosine, I should have it in degrees. If I don't have it, no, the alpha should be in radian. Alpha should be in radian. So alpha radian equal to pi over 180 by the angle, which is 0.412. Okay, this is just only for the conversion. And T1 is equal to alpha over omega, which is this one. Now alpha, the new alpha in radian, this is the one, and dividing by the omega in radian also, this is the one, equal to 1.09 milliseconds, or equal to 1.09 multiplied 10 to the power minus 3 seconds. Okay, for the second intersection, for the second alpha, I mean, alpha is equal to pi over 180 multiplied by this angle to change it in radian. خلاص, the second alpha, remember the second alpha. So T2 is equal to alpha over omega. Alpha is 2.73 divided by 377 is equal to 7.24 milliseconds, or you can write it 7.24 multiplied by 10 to the power minus 3 seconds. For the average value, it is the topic number 7 for the first video. Even though the concept of the average value is an important one in most technical fields, its true meaning is often misunderstood. If we let G denote the average value as follows: G average value is equal to algebraic sum of areas over the length of the curve. The algebraic sum of the areas must be determined since some areas contributes are from below the horizontal axis. So areas above the axis are assigned a positive sign, and those below it is a negative sign. So usually if you have three numbers like 3 plus 4 plus 5, so the average is equal to the average, let's say it is G average, is equal to, this is the one. خلاص, this is how to have the average value. Okay, so in this point I need to have this point, this point, this point, this is point, this is point, this is point, and this point, this point. So I have all the points here. Okay, so I should have integration here, but for you guys we will not show you the integration needed to have the average value of shape like this. So just I want to mention that the average just it is not only for the positive side, it should be also having for the negative side. Okay, so we have it for both. Okay, now for example, determine the average value of the waveform in 13.44, which is this one. Okay, guys, this one, the first one, okay, for A, this is goes to 10, and then go down to 0, and then to go went to minus 10 volt, and then go to 0. Okay, and so on, 10 to 10. That's why, because they are having 10 and minus 10, so they are the same actually. It is easier for us. So by inspecting here, guys, by inspecting the area above the axis equals the areas below over this with the one cycle. This is one cycle. Okay, guys, this is one cycle. Up to here, this is one cycle. Okay, this is one cycle. Okay, resulting in an average value of 0 volt using the equation. So if you have the same value, as I told you before, if you have the same positive value equal to the same negative value, okay, as a magnitude, so it is 10 and minus 10 as a magnitude, they are almost the same. They are the same, 10 and 10. Okay, so if I use this formula for finding the G value, the average value, so it says that it is 10 volt multiplying 1 milliseconds because it is for 1 milliseconds here. Okay guys, let me write with another color. Okay, this is 1 second, this is 1 second from here to here, this is 1 second, and this is 1 second, and this is 1 second, and this is 1 second. So I have, sorry guys, I have 10 volt for 1 second. I have here also 10 volt for 1 second. خلاص. So 10 volt multiplied by 1 second minus, this is it is important, no need to put the minus here because it is plus in the actual formula. It is plus minus 10 multiplied by 1. So actually this one will be here because minus plus minus, so it is, we will just also we will just write a minus, that's it. خلاص. So 10 multiplied by 1, so it is 0, they are the same value, it is 0 over 2 milliseconds, which is equal to 0. Now you will understand inshallah if you see the second paragraph, second waveform here. This is the second one. I have here 14 volt in 1 second, right? I have here minus 6 volt in 1 second. Okay, so the difference in both levels, in both levels they are different. So 14 multiplied by 1 second, because it's already 1 second between each values, minus 6 volt multiplied by 1 second also. So 14 minus 6 is 8, divided by 2 milliseconds, which is equal to 4 volt. 2 milliseconds. Why I say 2 milliseconds in this equation and this equation? Because the one cycle, because here said in one cycle, one cycle, it is starting from here. Okay, this is one cycle, guys, this is one cycle. One cycle ends in 2 milliseconds. Okay, 2 milliseconds. خلاص. That's why we are saying this is very important formula for the finding the average value. Okay. Now for the effective value, it is called the root mean square, which is RMS. This is the effective value. Okay, this is the effective value. The equivalent DC value is called the RMS, or effective value of a sinusoidal quantity. So if I have an AC wave, okay, if I have an AC wave, this is the effective value. The AC wave usually here, okay, let's say it is the value that I have it here is 127 volt. The RMS, this is what I got in the receptacle, guys. If you have if you connect your TV to the receptacle, you will find because the TV is working on 120 volt, you will find this value. This is the RMS value. And the peak value for the AC wave, this is the peak value. You will find different, like it is 160, I'm not sure, but this is the maximum value. Okay, and we will inshallah calculate it in the coming slides inshallah. Okay, we will calculate what is the maximum value here. Now so 127, let us calculate it here now. Okay, if you have a calculator, please find this formula and do it in the calculator. V peak is equal to V RMS multiply by root 2. Inshallah, the next slide you will see same as this one. The VRMS is 127 multiply by root 2, which is 179.6 volt. Now, because we are talking about the root mean square, which is RMS value, let us have an example here, a small example. Okay, let us say that the V peak equal to 160. خلاص. What is the RMS value? RMS value. So from this formula, okay, the VRMS, the effective value, is equal to V peak over root 2. V peak is 160 over root 2 is equal to 160 divided by root 2 is equal to 113.14 volt. خلاص guys, this is how to do the conversion between the V maximum and V peak and V RMS. Okay, so the equivalent DC value is called the RMS, or effective value, of the sinusoidal quantity. As a simple numerical example, it requires an AC current with a value of 14.14 ampere to deliver the same power to a resistor as a DC current of 10 ampere. So if I have a resistor, okay, that can handle that having now at this moment I have 10 ampere across the through the resistor. Okay, I have 10 ampere. If I need it in if I need to put the same resistor in AC wave, I should deliver to the resistor 14.4 ampere to have the same power. خلاص. The following set of relationships is the voltage and the current. Okay, if I have the RMS, if I need to have the RMS, I should just do IM, as I told you, which is the maximum over root 2. خلاص. Or I should use this one as a number, 0.707 multiply by IM. It is the same. Okay, if you need to memorize it as IM over root 2, or multiplying 0.707 by the maximum current. Okay, for the voltage it is the same. If you need to find the RMS value, you should just only divide EM over root 2 خلاص, or multiply 0.707 with EM خلاص. Now if I need the maximum or the peak value of IM, the peak value, it is an opposite, just only as I explained to you before. This root 2 multiply IRMS. Okay, or use this number, root 2 is also equal 1.414 multiplied by RMS. This is the same for the voltage. This is very simple and important formula. Inshallah, you are going to use it. You are going to use it in the coming examples. Okay. For this example, find the RMS values of the sinusoidal waveform in each part in the figure 13.60. So part A, okay, I need to find what? I need to find the RMS value. So this is the maximum value. So the let us solve it together. VRMS is equal to, if I need to have the maximum, so V peak over root 2, or it is equal to 0.707 multiply V peak. They are the same. Okay, the answer is 8.48 milliampere. ampere. Why it is in milli, guys? Why it is in milli? Because they are using a value here in milliampere, so the answer should be in milliampere. If you put it in the as it is here in the in a formula, if you substitute it in the formula, you should use milliampere, which is 10 to power minus 3, to have an answer in milliseconds. خلاص guys. For part B, I have also 12 as 12 milliampere, so the answer it is the same as the first one, even it is oscillating fast, as you can see here, fast. So I have here this is one cycle, this is second cycle. Okay, so I have two cycles here, one cycle, but they are also the same. They are the same because they are having the V peak is equal to 12. So we are concentrating on the V peak value to find the VRMS, not the omega, not the frequency of a circuit of this waveform, nothing. We just concentrating on the value of V peak, which is 12 here. Allah Akbar. Note that the frequency did not change. The frequency did not change the effective value in B compared to A. خلاص. For part C, VRMS, for part C here, this is the maximum value. This is the maximum V peak. So VRMS is equal to V peak divided by R2, which is this is 120 volts. This is the same as available from the home outlet. خلاص guys. This is so if you find it here in the receptacle at your home, you will find 120 volt. Having a V peak value, it is 169.73. Now, more examples for the effective value. Example 13.21, the 120 volt DC source in figure 13.61, okay, delivers 3.6 watt. So this is the load, 3.6 watt to the load. Determine the peak value of the applied voltage. Okay, if I have determine the peak value of the applied voltage EM and the current IM if the AC source is to deliver the same power. If the AC source, this is the AC source, we have now, he want to show you the comparison between AC source and DC source. Okay, this is 120 volt. Okay, we need to have the AC source, how much the V peak in the AC source. Now, we know that the power is equal to VI. Okay, so the IDC is equal to 3.6 divided by 120, which is 30 milliampere. This is already known from circuit 1. Now, for the I maximum, because I have already the DC, I maximum, or the peak value of I, is equal to root 2 multiplied by IDC, which is 1.414 multiplied by 30 milliseconds. It is 42.42 milliseconds. Now, for the value of V maximum, already I have the VRMS, which is 120 volt. Okay, multiplied by root 2, it is 169.68 volt. Yes, guys. This is a homework question. Inshallah, you can solve it, and I don't need it to submit it to me. But if you have a problem with the homework, you can just contact me, okay, or send it to Blackboard, or send it in the Telegram group. as you wish. Let me just explain to you the homework. For the periodic square waveform, what is the peak value? Okay, what is the instantaneous value at 1.5? 1.5. Okay, and 5.1. 5.1. What is the peak to peak value? Peak to peak value. What is the طبعا البيك to peak value, we know that V peak to peak, okay guys, equal to 2 V peak, 2 multiplied by V peak. خلاص يعني مرتين، البيك الواحد بعدين 2 peaks، 2 peak to peak يعني 2 ضرب V peak. Now what is the period of the time of the period of the waveform? T is equal to 1 over frequency. How many cycles that shown? This is, as I told you, this is 1 cycle, this is 2nd cycle, and you can find the rest. Okay, how many cycles are shown? Now for the second question, convert the following gradients to degrees from the formula. Try to solve it, because you need to practice using the calculator. That's why I'm just showing you these type of questions, because you will need it. Okay, find the angular frequency, which is omega, of the waveform of frequency. We know that the omega is equal to 2 by f. Okay, use the math. Okay, the last question is, an alternating voltage has an equation of V equal to 141.4 sine omega t. So this is V maximum, this is sine, and this is omega t. Okay, what are the values of the RMS voltage? This is V peak, this is V peak. You need to have the V RMS using the formula. Sorry, frequency, you already have the omega, so omega is equal to 2 by f. خلاص. C, what is the instantaneous value, the instantaneous voltage when t equal to 3 milliseconds. خلاص. We just apply the formula, apply the general format with time is 3 milliseconds. Okay, I will not solve it for you. This is the trick here. You can inshallah find it and think about it. If you have any problem, just contact me. By any means you want, I already give you a Telegram group. I already have you in the Blackboard. If you have any question, just contact me. Thank you so much for listening to this video. I know it is too long, but I couldn't make it with less time. Alhamdulillah, I finished lecture 1. Thank you so much, and stay safe.